Okay, welcome back. It is almost the same numerical in this. If somebody asks you that you have to find out the moment of inertia about its baseline. This baseline is, let us say, this is the baseline. Let us say AB, right? You have to find out the moment of inertia about this baseline, already identified given line. Now, whenever it is, they say this type of condition, then there is no need for you to find out the its centroid and moment of inertia, right? Of course, you can draw the table. You can draw this type of table, but if you know the formulas of their area and location of centroid, then you can always draw, you can just put the formulas into one single bigger formula, right? So, see, it is like this. IAB is equal to I1. See, this is the phi 1, this is 2, this is 3, and this is 4. This 4 is actually, it is cutted out of it. So it is I1 plus I2 plus I3 minus I4. And IAB is, see, about this line you already know, pi by 128 d to the power 4. Diameter d is 8 to the power 4. But you have to find out the moment of inertia about this line. And how much is this distance? It is 4. Okay. So what you will do is plus area of the A1 multiplied by 4 ka whole square plus second. Second is, for second shape, for this shape, you know the moment of inertia about this line, right? But you have to find out the moment of inertia about its, and the distance is this only. So it is, this red line is cutting this line, vertical line. So it is, length is how much? 8. So 8 whole cube multiplied by 8 upon 12 plus area multiplied by 4 ka whole square plus third one is this shape. For this shape, you know the moment of inertia about its this line. This is the centroidal. What it is? 8 whole cube into 4 upon 36 plus area of the shape, area multiplied by distance is this distance. And what is this distance? H by 3. H by 3 means H by 3 means 8 by 3 and whole square, right? Okay, then minus corresponding to this. For this circle, we know it is pi by 64 d to the power 4. D is 4 to the power 4 and plus, see, we have to apply the bigger bracket plus area of the shape, area multiplied by this distance, and this distance is already known to me, 4 ka whole square. So whenever in any question if it is given that you have to find out moment of inertia about any identified given line, then there is no need for you to calculate the centroid and moment of inertia. Sorry, centroid, right? You can directly calculate the moment of inertia like this. Okay, thank you.